Hi, this is the next video for the year 2 Pure. We're going back to look at the trig, and we're working towards 7a. Now, if you look at example 1 and example 2, and example 1 is just looking at a diagram. I'm not going to redraw the diagram for you. You can have a look at example 1 yourself. Example 2, whilst it's interesting to look through, it's not really required that we need to do that. We're given these identities, sine a plus or minus. This is how they're presented in the formula booklet. So example 1 really just goes through deriving these, but as I say, we're given them anyway. Cos of a, now I've got to be careful here because the signs actually change. Cos a, cos b, minus, plus, minus. So the sine, so this is saying sine of a plus b is sine a cos b plus cos a sine b. But if it's a minus b, then it's sine a cos b minus cos a sine a. If it's cos of a minus b, then it's cos a cos b plus sine a sine b. Nearly said it wrongly then. So we've got to be careful with the signs. And we're also given tan of, let's have a look at the formula booklet. Tan of a plus or minus b is identical to tan a plus or minus tan b over 1 minus or plus tan a tan b. Now, of course, we're also given a qualifying statement that talks about the values of a and b such that this denominator won't be equal to 0. Now, generally, there is all going to be done in radians. I'm just looking through and checking that is the case. Generally, questions in trig will be done in radians, but they do also apply for degrees to these identities. So we do need to be careful for each question what a question expects us to do. So I'm not going to do example 1, I'm not going to do example 2. Example 3 is straightforward enough. Show that these prove this identity and it's really just, oh, hang on a minute, there you go. So if I look at the left hand side and try to write these as a single fraction, of course my common denominator will be sine b cos b, so straight away I'll get the denominator that I want. Multiply top and bottom by cos b, so I'll get cos a cos b minus, multiply top and bottom by sine b, so I'll get sine a sine b, and given the formula in the formula booklet, there you go, look, cos a cos b minus sine a sine b is equal to cos of a plus b. So that is a fairly straightforward algebraic manipulation. Example 4 is a little bit more interesting. 2 sine x add y equals 3 cos x minus y. It wants tan x to be some function of tan y. So clearly I'm going to try to get sine x over cos x, because that's equal to tan x. And to do that, I'm going to have to expand these brackets. Now, it's not actually expanding brackets, is it? This is not a multiplier. I'm going to use the addition formula that I'm given. Sine x plus y, sine a plus b. So 2 sine x plus y will be sine x cos x, sine x cos y, sine x cos y plus cos x sine y. That's equal to 3 cos of x minus y, well, a minus b. You have to just go onto this line. 3 cos x cos y minus sine x sine y. Let's go on to the next page. I'll write it out again. I'll expand the brackets. 2 sine x cos y add 2 cos x sine y equals 3 cos x cos y minus 3 sine x sine y. Now remember, I've got to bear in mind what I'm working towards. I'm working towards tan x. So sine x, I'm going to have to divide by cos x. So the first thing I'm going to do is just divide through by cos x. Divide each term by cos x gives me 2 tan x cos y plus 2 sine y, because cos x over cos x is 1. Cos x over cos x is 1, so 3 cos y minus 3 tan x sine y. So I've got my tan x's in. I need tan y as well, so these sine y's I need to divide through by cos y. 2 tan x divided by cos y. Sine y over cos y is tan y. Oh, this is all working out very nicely. 3 tan x tan y. And then I just need to make tan x the subject. So tan x, I've got 2 plus 3 tan y. I just realised I've done it wrongly. I've changed the sign. There you go, sorry about that. Equals 3 minus 2 tan y. Divide both sides. 3 minus 2 tan y over 2 minus 3 tan y. Done. And that's it, but I just want to do a couple more examples because there's nothing really in any of these examples to help us with question 9 or question 10. So I'm just going to look at 9a. Sine 15 degrees cos 20 degrees plus cos 15 degrees sine 20 degrees. So look, I've got sine A cos B plus cos A sine B. Or if I think about sine A, if I think about what identity that will be, that's going to be sine of A plus B, just from the identities that I've given. So sine 15 cos 20 plus cos 15 sine 20 must be the sine of 35 degrees. So essentially, what identity does it look like? Question 10 is similar, but we're going to have to multiply out those brackets. 1 over root 2 sine x plus 1 over root 2 cos x. Now this looks like sine A times something and cos A times something. So I think this is the same identity. If we think about sine A cos B plus cos A sine B, well, what if cos b is 1 over root 2? That's 45 degrees, isn't it? Let's go back into degrees. $45. B is 45 degrees. And also, if sine b is 1 over root 2, it's also 45 degrees. So I can say sine x cos 45 plus cos x sine 45. Of course, then that's going to be equal to sine of x add 45. So question 10 is also an interesting one. Question 11, expand, rearrange. Question 12, very much like the example we did. I'll leave you to do the rest of it. So it's a useful exercise to get used to using the addition formulae. I'm not so fussed that we can derive the addition formulae. Incidentally, 7b is quite similar using the addition formulae, but we'll obviously come to that next time. Okay, let me know if you need anything.